Welcome to the Dali64 Silk Integration Module. This module will assist you to integrate the Dali64 sensor into your BMS, using an P5 IRM Room controller, and Saia PCD Supervisor. When you are ready, please click Next. The P5 IRM Room controller has a polarity-independent 2-wire silk interface, which is compliant to Honeywell Silk's specification. The Dali64 Silk PSU can be seamlessly integrated into the P5 IRM system and Saia PCD Supervisor over this silk interface. The SBC system uses silk COVs, and there is no need to create or upload send tables or proxy files to the device. The objective of this course is to show how to integrate a commissioned Dali64 Silk sensor into a SBC Saia Burgess controls BMS system, using an P5 IRM Room controller and Saia PCD Supervisor. Using P5 to create the integration strategy, and show Saia PCD Supervisor graphic page to display and adjust values. It is recommended that the sections are watched in order from the top down. However, if you are revisiting this course, you can select the sections in any order. Please click a button to continue. Electrical contractors and BMS engineers often use the different words for the same items. This page will help clarify some definitions. Here you can see the example of pivot list. Using the pivot listing, inputs and outputs of the interface module can be easily defined. Pivot is the unique identifier for each point on the silk bus. The first digit of a pivot is used to indicate direction from device point of view. Therefore, all pivots identified as read are indicated as an output with first digit set to 1. All pivots indicated as write will be an input with first digit set to 2. Bidirectional pivots will have their first digit set to 6. The second digit is set to the device address on transmit, and it is shown as 0 in the pivot table. Controller firmware internally corrects this based on interface module configurations, and there is no need for user to change this digit. The SBC system uses silk COVs, and as such there is no need to create or upload send tables or proxy files to the device. Where to find all the related documentation? All related documentation can be found in the SBC support web portal, such as firmware for PCD7 controller and some P5 room template. In addition, there is also a P5 Dali64 template project for the P5 IRM, PCD7.LRxx-P5, available, which can be used as starting point. Any modification about demo application and library will be published and update on the official SBC support web portal. Following project application demo is based on PCD7.LRxx-P5 module. First, click on the Library Manager and choose the library you require in the system view. Before we start programming, the controller type must be configured. Then configure the network interface. In principle, for a better understanding, and to facilitate the commissioning experience, is suggested to maintain the following structure. Applications splitted in pages referred to the topic covered. And it can also be extended based on the complexity of project designed. Pages can be then freely customized by the partner as well, depending on the design specification and light touch app project realized. To get better familiar with application sample, additional tips and notes based on labels have been added to the SW application pages. Example of silk bus life check, where you can see increasing counter equals, bus up, and running. And also, you can see the example of Dali64 Silk Master Sensor Refbox. Values definition. Here you can see predefined list of values mapped to the application pages. Helpful page to easily list all the variable pivot reading implemented in the application. Remember, no need to create a specific application watch list for the scope. Here, you can see example of Dali Group Control Fbox. Based on the application created via Honeywell Light Touch app, is possible monitor and command Dali groups. For example, LIFO CC output, monitor the occupancy detection. Group 0 is the default group associated by the Honeywell Light Touch app. It's often used to switch on and off all the gears. The related DALI command could be associated and a time-based event from the BMS, in order to issue, for example, a time schedule feature. All gears discovered on the bus by the Honeywell Light Touch app during the commissioning will be grouped here, without any possibility of custom modification. Here is the example of generic F-box for reading pivot silk bus data packet. For example, gears error OXX equals 0 means no gear in error. OXX equals 1 means gear error is detected. 002 set to 1 means that gear 002 is disconnected from the DALI bus. Here you can see the example of generic F-box for writing pivot silk bus data packet. Example of how to impose a light level on group 0. On the top is group 0 pivot address. Then, light level value, in our case it is 50%. And if you click here on group 0 level right, that will execute a trigger feature in order to send the above defined command over the DALI bus. And also, there are some application hint. The specification for the lighting allows for a single group of 12 lights, which will automatically switch on when presence is detected in the room. If no presence is detected for 20 minutes, the lights will dim. To warn the user, they have to be detected within 4 minutes, otherwise, the lights will switch off. 3 scenes are configured on our sensor. Scene 1 equals all lights are on, which is light level 100%. Scene 2 equals whiteboard row lights are on, at level 100%. And all others off, at 0%. And scene 3 equals whiteboard row lights are off, at 0%. And all others on, at 80% light level. Light level regulation and emergency lighting are not covered in this example, but the principle to include them is the same. Our sensor is set to address 3 on the silk bus. Firstly, log into PCD Supervisor. We will start with the lighting off. Once occupancy is detected, the light will switch on, at scene 1, equals all lights are on. The scenes can be changed by using the physical scene plate, or the BMS virtual scene plate. Switching to scene 2, will leave the first row of lights on, and switch the rest of the lights off. Switching to scene 3, will switch the first row of lights off, and the rest of the lights on. Switching to scene 1, will switch all lights back on. If no occupancy is detected, the lighting automatically switch off after a time delay. And at the end, just log off from PCD Supervisor.